CIET NCERT presents the audiobook Curiosity, Textbook of Science for Class 6.
Chapter 5 Measurement of Length and Motion. Page 79. Deepa, a curious 11-year-old girl, lives in a town of the state of Haryana. The new school year has started. Deepa needs a new uniform since she has grown taller. Her mother takes her to a cloth shop. She asks for 2-meter cloth piece. The shopkeeper measures the cloth using a metal measuring rod. On the top of the page is an image of a school girl. Then the tailor takes her measurements using a flexible measuring tape. Her mother instructs the tailor to increase the length of a uniform by 4 angula, 4 fingers width. On the bottom right of the page is an image of a schoolgirl thinking. Are the tape and rod similar to the scale that the elder sister has in a geometry box? What did mother mean by 4 angula? On the bottom of the page is an image of a scale. Deepa shares her experience with her school friends Anish, Hardeep, Padma, Tasneem, and this leads to a discussion amongst them. Page 80. On the top of the page is the image of school children in conversation about what Deepa said. The children in the image are Deepa, Anish, Hardeep, Padma, and Tasneem. Section 5.1. How do we measure? Hardeep says, I have seen my grandmother measuring cloth by the length of her arm. Have you ever seen how a farmer measures length to divide his field into beds? He walks and counts the number of his strides, says Padma. Oh, not just the length of the strides. Sometimes they use the length of their feet to measure, adds Anish. Deepa says excitedly, measuring length using body parts must be so much fun. Let us also measure something using a body part. What should we measure? Okay, let us measure the length of the table in our classroom, says Tasneem. Padma adds, and which body part should we use to measure it? Deepa says, let us use our hand span. I will show you how to use it. I have seen my mother using it. She calls it balisht. Hardeep adds, okay, let us also note down our measurements. On the bottom of the page is the image of a child using a handspan to measure. Page 81. Table 5.1. Measuring the length of the table. In this table, there are 2 columns. Name of the student and number of handspans. Row 1. Anish. The number of handspans of Anish is slightly more than 13. Row 2. Padma. 13 is the number of handspans of Padma. Row 3. Tasneem. Slightly less than 13 is the number of handspans of Tasneem. Row 4. Deepa. Between 13 and 14 is the number of handspans. Row 5. Hardeep. 14 is the number of handspans used by Hardeep to measure the length of the table. Padma says, oh, the number of handspans is different for all of us. So what can we say about the length of the table? But why should the number be different? Hardeep asked thoughtfully. Tasneem says, I can guess. Our handspans are of different sizes. Anish gives an idea. Let us check this. So all 5 of them put their handspans along each other and arrive at the conclusion that the lengths of their handspans are different. Deepa says thoughtfully, no wonder people use scales and measuring tapes. Deepa and her friends compared the length of the table with the length of their handspans. The length of the table is expressed in terms of their handspans. Here, the handspan used for measurement is an example of a unit, and the length expressed in 2 parts, a number and a unit. For example, if the length of the table is found to be 13 handspans, then 13 is the number and handspan is the unit selected for the measurement. However, handspans and other similar units such as length of hand, foot, fists, or fingers differ from person to person. Thus, there is a need for such a unit for which measurements of the same length may be made by different people do not differ. Page 82. On top of the page is a box with the title More to Know. India has a rich history of measurement systems dating back to ancient times. Angula, finger width, multiples of angula, dhanusha, and yojana are some of the units mentioned in ancient Indian literature and used in measuring artifacts, architecture, and town planning. The angula is still used by traditional craft people like carpenters and tailors. Several objects with ruled markings, which could be scales, have been excavated from the sites of the Harappan civilization. Section 5.2 Standard Units. Several systems of units evolved with time in different parts of the world. However, when people started traveling from one place to another, it created a lot of confusion. This led to the different countries coming together and adopting a set of standard units for measurement. The system of units now used is known as the International System of Units or SI units. The SI unit of length is meter. Its symbol is M. On the right side of the page is an image of a meter scale. 1 meter is divided into 100 equal divisions. Each division is called a centimeter, cm. You may be familiar with a smaller part of the meter scale. Typically, that is a scale 15 centimeters long. In a 15 centimeter scale, there are markings in centimeters from 0 to 15. The length of any section between two consecutive big marks, such as between 1 and 2 or between 5 and 6, is 1 centimeter. Observe that these sections of 1 centimeter length are further divided into 10 equal parts. Page 83. The length of one of these smaller parts is called a millimeter. 1 millimeter is the smallest value of length that you can measure using this scale. 1 millimeter is equal to 1/10 of a centimeter. 1 mm is equal to 0.1 cm. In the middle of the page is a box with a question. Would it be convenient to use a unit meter to measure larger lengths, such as the length of a railway track between two cities, or to measure smaller lengths, such as the thickness of a page of a book? For measuring larger lengths, we use a larger unit called a kilometer, which is equal to 1000 meters. And for measuring smaller lengths, we use units such as centimeter or millimeter. In the center is a box with the equivalents of measurement. 1 kilometer is equal to 1000 meters. 1 meter is equal to 100 centimeters. 1 centimeter is equal to 10 millimeters. On the bottom of a page is a box with the title, Do You Know? The box also has an image of a scale. In some scales, you might have noticed another scale marking. This scale markings is in inches, where 1 inch is equal to 2.54 centimeters. In earlier days, units such as inch and foot were used to measure length. These units are still used by some people. Page 84. On the top of the page is the image of a schoolboy and schoolgirl having a conversation. The boy asks, "Suppose we all measure the length of the table again, but this time using a meter scale. Will our results still be different?" The girl replies, "No, but we should first learn the correct way of using a scale to measure length." Section 5.3 Correct way of measuring length. For measuring any length, we need an appropriate scale. For example, if you want to measure the length of your pencil, you may use a 15 centimeter scale. Similarly, if the height of a room is to be measured, you may need a meter scale or a measuring tape. You cannot directly measure the girth of a tree or the size of your chest using a meter scale. For such measurements, flexible measuring tape, such as a tailor's tape, is more suitable. While measuring lengths, we need to take care of some points. What is the correct way to place the scale? Place the scale in contact with the object along its length. On the bottom of the page is the image of the correct method to place the scale. The correct way shows the scale aligned to the paper horizontally, while the incorrect method image shows the scale placed slightly slantingly. What is the correct position of the eye while reading the scale? For example, if you are trying to measure the length of a pencil by aligning it with a scale, the position of your eye should be directly above the tip of the pencil. Page 85. On the top of the page is the image of the correct method to measure the length of a pencil using a scale. In the correct position, the position of your eye should be directly above the tip of the pencil. How to measure the length if the ends of the scale are broken? If the ends of the scale are broken or the zero marking is not clear, it can still be used for measurement. With such a scale, use any other full mark of the scale, say 1 centimeter. Then you must subtract the reading of this mark from the reading at the other end. For example, the reading at one end is 1 centimeter and the other end is 10.4 centimeters. The length of the object is 10.4 centimeters minus 1 centimeter, that equals 9.4 centimeters. In the middle of the page is the image of the correct method to place a scale with a broken end. The image tells us that if the zero mark is broken, we can place the scale on the 1 centimeter mark on the edge of the paper to measure its length. On the bottom of the page is a box with the title, Do You Know? There is an image of a scale used by visually challenged students. How do visually challenged students measure lengths? They use scales with raised markings that can be felt by touching them. Page 86. Activity 5.1. Let us measure. 1. Select some objects around you, such as a comb, a pen, a pencil, and an eraser to measure their lengths. 2. Measure their lengths one by one using a meter scale and note down the measurements in Table 5.2. Table 5.2. Measuring lengths. This table has two columns, where the first column is the object and the second column is the length of the object. Choose the objects from around you and write their lengths in 4 rows given below. In the middle of the page is the image of a schoolboy thinking, why are some length measuring devices made up of flexible material? While writing the length, do not forget to write the unit also. Thus, your result will consist of 2 parts. One part is a number and the other part is the unit of the measurement. Some of your friends in the class would have measured the length of the same object. Compare the lengths measured by you with that of your friends. Are the measured lengths the same or slightly different? If not the same, discuss the possible reasons for the differences. On the bottom of the page is a box with the title, Do You Know? Units of length such as kilometers, meters, centimeters, and millimeters begin with a lowercase letter, except at the beginning of a sentence. Their symbols km, m, cm, and mm are also written in lowercase letters. and are never followed by an S for the plural. Note that a full stop is not written after the symbol except at the end of the sentence. While writing the length, always leave space between the number and the unit. Page 87, Section 5.4. Measuring the length of a curved line. On the top of the page is the image of a house decorated with string lights. Anish and his parents fixed electrical string lights on the arches of the veranda of their house for a celebration at home. How would they have measured the required length of string lights? In the case of a curved line, measurements can be made with the help of a flexible measuring tape or by using a thread. In the center of the page is an image of the correct method to measure a curved line. The correct way shows that the scale or the thread is aligned along the length of the curved surface. The thread can then be straightened and its length can be measured using a meter scale. Section 5.5. Describing positions. On the bottom of the page, there is an image of the location of the bus stand, school garden, houses of Deepa and her friends. The image shows the positions from left to right. The positions of the bus stand, school, Deepa's house, Anish's house, Hardeep's house, Tasneem's house, Padma's house, and the garden are given. One day, the teacher informs her students that she has planned an educational visit to a nearby garden. She asks the students to reach there directly in the morning. Deepa and her friends start discussing whether the garden would be closer than their school or farther. Tasneem and Padma say the garden would be closer, while Deepa and Anish feel that the school would be closer. Hardeep thinks that both would almost be at an equal distance. Page 88. Who do you think is correct? All of them are correct. Then why are their observations different? They are locating the distances of the school and the garden from their houses. If instead each of them had thought of distances from a same object or point, say the bus stand, then their observations would have been same. When distance is stated with respect to a fixed object or a point, then this point is called the reference point. A few days later, Hardeep tells his friends excitedly, "Let us all go to the playground. The sports teacher wants us to help her draw lines with chuna powder, limestone powder, for making the kabaddi court for the sports day." Padma says, "We need a longer measuring tape. Let us take it from our sports room." On the left-hand side is an image of a measuring tape. Deepa, "Let us first decide the point on the ground from which we will measure the distances to start drawing the lines. Let us call this our reference point." On the bottom of the page is the image of school students drawing lines for a kabaddi court. The students are using a reference point to draw the lines of the kabaddi court. Page 89. After a few days, Padma was travelling by bus to visit her grandparents in Delhi. She was eager to reach Delhi and was reading the kilometre stones on the side of the road. On one of the kilometre stones, it was written, "Delhi, 70 kilometres." On the left-hand side of the page is an image of a kilometre stone that reads, "Delhi, 70 kilometres." Further on, the next kilometre stone read, "Delhi, 60 kilometres." Each kilometre stone indicated to her that she was getting closer and closer to her grandparents' house. These kilometre stones indicated her distance from Delhi. So Delhi is the reference point in this situation. In the middle of the page is a box with a question. What do such kilometre stones indicate? How could Padma conclude that she was getting closer to her destination? On the middle of the page is an image with positions of kilometre stones with respect to Delhi as reference point given. If the kilometre stone reads Delhi 70 kilometres, we can say that the position of Padma is 70 kilometres from Delhi. When the kilometer stone reads Delhi 60 kilometers, the position of Padma is at 60 kilometers from Delhi. At the bottom of the page is a box with a question. Does this mean that the position of Padma with respect to the reference point is changing with time? When does the position of an object change with respect to a reference point? Does it change when an object is moving along? Page 90, Section 5.6, Moving Things. Activity 5.2. Let us explore. 1. Look around and prepare a list of 5 objects that are in motion and 5 objects that are at rest. Record your observations in Table 5.3. Table 5.3. Observing things around you. In this table, there are 4 columns. Objects in motion, justification. Objects at rest, justification. Row 1. Cow grazing in the field is the object in motion. What is your justification? Objects at rest, tree. What is your justification? In the below rows, fill in the objects in motion around you and give an explanation or justification as to why you think it is in motion. In the rows below the objects at rest, give an explanation as to why you think these objects are at rest. 3. Think about how you decided whether an object was in motion or at rest. Write your explanation, justification in Table 5.3. Compare and analyze your justifications. How can one decide if an object is in motion or at rest? An object is said to be in motion if its position changes with respect to the reference point with time. If an object is not changing its position with respect to the reference point with time, it is said to be at rest. Page 91. On the top of the page is a box with the title, More to Know. Deepa looked around in the bus and noticed that all passengers were seated. She looked around again after a minute and found them still occupying their seats. She wondered, are they moving? She concluded that the position of the passengers was not changing with time. Therefore, they were certainly at rest. However, when she looked outside, she felt they were in motion as their positions were changing with respect to the things outside. The reference point is an important point in deciding whether an object is at rest or in motion. If Deepa considered herself or the bus as the reference point, then the passengers were at rest. However, if she considered any object outside the bus, say a building, as the reference point, then the passengers and the bus were in motion. In the middle of the page is a box with the title, Think It Over. Suppose you're traveling on a ship which is moving at a constant speed along a straight line on a calm sea. Suppose there is no window on the ship. Is there any way you can determine whether the ship is moving or is stationary? Section 5.7, Types of Motion. Activity 5.3. Let us explore. 1. Take an eraser and drop it from a certain height. 2. Observe its motion. Does it move along a straight line? When an orange drops from a tree, does it move in a straight line? Have you seen the Republic Day parade? Recall the march past of students during the parade. Do they move on a straight line path? When a heavy box is pushed, it may also move along a straight line. Page 92. When an object moves along a straight line, its motion is called linear motion. Identify such linear motion in your surroundings. On the center of the page are images of examples of linear motion. There are 4 examples. 1. Of a magnet falling. 2. A boy pushing a heavy box. 3. A fruit falling from a tree. And 4. Schoolgirls marching on the road. But do things always move along a straight line? You might have enjoyed playing on the swings and merry-go-rounds. Are these types of motion also linear motion? Activity 5.4. Let us investigate. 1. Tie an eraser or a potato at one end of the thread. 2. Hold the other end of the thread with your hand and whirl it. 3. Observe its motion. Is the motion of the eraser the same as that of a merry-go-round? When an object moves along a circular path, its motion is called a circular motion. Page 93. On the top of the page is the image of a circular motion. The first image is of a schoolgirl swirling a potato over her head, and the second image is that of a merry-go-round. Activity 5.5. Let us investigate. 1. Tie an eraser or a potato at one end of the thread. 2. Hang the eraser by holding the other end of the thread. Keep your hand steady. 3. Using the other hand, take the eraser slightly to one side and then release it. Does it start moving to and fro? Is its motion similar to the motion of a swing? When an object moves to and fro about some fixed position, its motion is called oscillatory motion. On the bottom of the page is an image of examples of oscillatory motion. In the first example, an eraser is tied to the end of the string and is moved in a to and fro motion. In the second image, a schoolboy is swinging on a swing. Page 94. Activity 5.6. Let us investigate. 1. Take a thin metal strip of about 50 centimeters long. 2. Hold one end pressed onto the table. You may use a few books or a brick to hold it. 3. Press the free end of the strip slightly and let it go. 4. Observe the motion of this end of the strip. Does it move up and down? This is also an example of an oscillatory motion. On the center of the page is an image of an example of oscillatory motion. A metal strip is placed on the edge of the table and books are kept over the metal strip to keep it in position. The free end of the metal strip is then oscillated. On the middle of the page is a box with the title, More to Know. If an object repeats its path after a fixed interval of time, its motion is said to be periodic. When an object is in circular motion, it moves along a circular path again and again. When an object is in oscillatory motion, it also repeats its motion while moving to and fro. Both circular and oscillatory motions are periodic in nature. Activity 5.7. Let us identify. 1. Visit a children's park. On page 95, on top of the page is an image of a children's park where children are playing. One child is sliding down a slide. One is swinging. One is on the merry-go-round. One is on the seesaw. One is on the balance bar. All these activities depict types of motion observed in a children's park. 2. Observe different kinds of motions. Classify them as linear, circular, or oscillatory motion. List them in table 5.4. Give your justification for why you put each in a certain category. Page 95. Table 5.4. Types of motion. In this table, there are 4 columns. The first column is object. The second is linear motion. The third is circular motion. And the fourth is oscillatory motion. Row 1. Swing. Swing has an oscillatory motion. Use the 4 rows below to write whether the activities in the children's park are of linear motion, circular motion, or oscillatory motion. Page 96. Keywords from this chapter. Centimeter, circular motion; distance, kilometer; length, linear motion; measurement, meter; millimeter; motion, oscillatory motion; reference point, SI unit of length; classify, explore, identify, investigate, justification, observe. Summary, key points. First, the International System of Units, SI units, has been adopted by countries as a standard unit of measurement. Second, the SI unit of length is meter. Its symbol is M. Third, 1 kilometer is equal to 1000 meters. 1 meter is equal to 100 centimeters. 1 centimeter is equal to 10 millimeters. Fourth, when the distance is stated with respect to a fixed object or a point, then this point or object is called a reference point. Fifth, an object is said to be in motion if its position changes with respect to a reference point with time. Sixth, when an object moves along a straight line, its motion is called linear motion. Seventh, when an object moves along a circular path, its motion is called a circular motion. 8. When an object moves to and fro about any fixed position, its motion is called oscillatory motion. Page 97. Let us enhance our learning. Question 1. Some lengths are given in column 1 of table 5.5. Some units are given in column 2 of table 5.5. In table 5.5, there are two columns. Column 1, rows, distance between Delhi and Lucknow, thickness of a coin, length of an eraser, length of the school ground. Column 2, centimeter, kilometer, meter and millimeter. Match the lengths with the units suitable for measuring those lengths. Question 2. Read the following statements and mark true or false against each. 1. The motion of a car moving on a straight road is an example of a linear motion. 2. Any object which is changing its position with respect to a reference point with time is said to be in motion. 3. 1 kilometer is equal to 100 centimeters. Question 3. Which of the following is not a standard unit of measuring length? Option 1, millimeter. Option 2, centimeter. Option 3, kilometer. And option 4, handspan. Question 4. Search for the different scales or measuring tapes at your home and school. Find out the smallest value that can be measured using each of these scales. Record your observation in a tabular form. Question 5. Suppose the distance between your school and home is 1.5 kilometers. Express it in meters. Page 98, question 6. Take a tumbler or a bottle. Measure the length of the curved part of the base of the glass or bottle and record it. Question 7. Measure the height of your friend and express it in meters, centimeters and millimeters. Question 8. You're given a coin. Estimate how many coins are required to be placed one after the other lengthwise without leaving any gap between them to cover the whole length of the chosen side of a notebook. Verify your estimate by measuring the same side of the notebook and the same size of the coin using a 15 centimeter scale. Question 9. Give two examples each of linear, circular and oscillatory motion. Question 10. Observe different objects around you. It is easier to express the lengths of some objects in millimeters, some in centimeters, and some in meters. Make a list of 3 objects in each category and enter them in Table 5.6. Table 5.6. Sizes of objects around us. Column 1. Sizes. Millimeters, centimeters, and meters. Column 2. Objects. Fill in the respective objects that can be measured using the corresponding units, as given in column 1. Question 11. A roller coaster track is made. A roller coaster track image is given on the right side. A roller coaster track is like a wavy, twisting road with high climbs, fast drops, and sharp curving turns. A ball starts from point A and escapes through point F. Identify the types of motion of the ball on a roller coaster and corresponding portions of the tracks. Page 99. Tasneem wants to make a meter scale by herself. She considers the following materials for it: plywood, paper, cloth, stretchable rubber band, and steel. Which of these should she not use and why? Question 13. Think, design, and develop a card game on conversion of units of length to play with your friends. Learning further. 1. Can you find the thickness of a single page of your notebook or textbook using a scale? Think of a way and write it. Carry out the activity and report your result. 2. Collect fallen leaves from the same tree. Identify the name of the tree whose leaves you have taken. Measure length and breadth of all these leaves using a 15 centimeter scale. Record your observations in Table 5.7. Table 5.7. Length and breadth of leaves. In this table, there are 4 columns. Serial number 1, name of the tree, length of the leaf, breadth of the leaf. There are 3 rows given which have to be completed by you. In the middle of the page is an image showing how to measure the length of the leaf and the breadth of the leaf. Discuss why the leaves of the same tree vary in length and breadth. Page 100. 3. Discuss with elders in your community what units were used for measurement of length in the olden days. Also, using the internet, try to find out about the length scales found in excavations of archaeological sites in India. 4th. Create a maze using lines of 1 centimeter, 2 centimeter and their combination. An image of a maze is given on the left-hand side. Now use your imagination and expand it to a size as big as you want. 5th. How tall am I? Stand along the wall and with the help of an adult, mark your height. There is an image on the right side of a mother measuring the height of her daughter. Repeat it every 3 months and maintain a height record for yourself and your siblings. 6th. Let us design a fun method for measuring the distance between 2 places by using a bicycle. Attach a flexible metal strip to the spoke of the front wheel in such a manner that it hits the frame of the bicycle holding the wheel every time it crosses and produces a sound. In the bottom of the page, an image of a bicycle is given. Now ride the bicycle slowly and count the number of times in which the sound occurred. The number will give you the number of turns of your wheel made. Now measure the length of the outer boundary of the wheel using a string. Multiply this length by the number of turns of the wheel. This is the distance you traveled. Such methods are actually used to measure the distance for road running races. Try to find out about a Jones counter which is attached to a bicycle and is used for measuring distances. Chapter 5 ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Class 6. Narration, Dr. Pranita Gopal. Technical coordination, Bati Langlingdo. Sound recordist, Virendra Rawat. Assistance in production, Amarjeet Sarkar. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.